program, I have made three parts. In one part, program is written. After that, I have written the meaning of each line of the code. And the third part is output that we will get after execution of each instruction. Now let's start with the program. The first line of the program is org00h, which indicates starting of the program. Org is nothing but origin directive, which is used to indicate start of the program. At the starting of every assembly language program, we need to write this org directive. Now, the next is move a comma hash F9H. The meaning of this line is we are moving the hexadecimal number that we want to convert into decimal equivalent into register A. And as an output, I have taken A is equal to 249 because when we do the calculations, we need its decimal equivalent for calculation. And therefore, I have mentioned A is equal to 249 as an output. Now, let's go for next line, that is move B, comma, hash 0AH. We are moving the number 0AH, that is nothing but 10 in decimal, into register B. Why we have taken A or 10? Because we want to convert hexa number into decimal equivalent. The base of decimal number is 10 and therefore we have taken 0A or 10 into register B. And therefore I have written B is equal to 10. As an output, here I am taking the values in decimal equivalents because it will be easier for me to do the calculations when I take the numbers in decimal equivalents. So for number F9, I have taken 249, which will go in register A, and in register B, you will get number 10. Now, when you will execute this code in Kill Microvision, in Kill Microvision register window output, we will be getting the hex numbers only. This output I have written for calculation purpose only. Now the next instruction is DIVAB, means we are dividing A register by B. DIV instruction is division instruction, and after execution of this instruction, the quotient will go to register A and remainder will go to register B. When I divide the number 249 by 10, then I will get as a quotient 24 and remainder will be 9. This is my first quotient and remainder that I have mentioned here. So when I execute this code, in register A after division, I will get hexadecimal equivalent of 24 and hexadecimal equivalent of 9. Now let's go for next instruction. Move R0, B. That is, we are moving the contents of register B into register R0. Here, if you observe, in the last step we got B is equal to 9. Now in this step we are doing what? We are moving the contents of register B into R0, means this 9 will be moved into register R0 because 9 is present in register B and that content we are moving in register R0, and therefore in register R0 we will get 9. The next instruction is move B, hash 0AH. Again in register B we are taking the value 10 or 0A for division purpose, and therefore now my B becomes 10 because I am moving the number 10 or 0A in register B. Now the next step is, again I am doing the division operation. I am using the instruction divab. After division, the quotient will go to register A and remainder will go to register B. Now in my case, I have A as a 24 here, and now my B is 10. So when I divide this A by B, that is, this 24 will be divided by 10, right? So when 24 is divided by 10, I will get A is equal to 2 as a quotient and B is equal to 4 as a remainder. So this is how I am doing the division operation second time, and I am noting down the quotient and remainders. Quotient will be stored in register A and remainder will be stored in register B. And therefore I am getting this answer as A is equal to 2 and B is equal to 4. Now what is next step? Move R1, B. Whatever content I have in register B, that will be moved in register R1. So R1, this is the general purpose register I am using. So here move the contents of register B to R1. Now if you observe in the previous step, the value of B is what? 4. And therefore in register R1 I will get 4 because previously I have B value as a 4. So this is how I am getting R1 as 4. Now next step is move R2, A. That is, we are moving the contents of register A to R2 register. So if you observe the previous steps, in A register you have 2, and therefore in R2 register the value of register A, that is 2, will be moved, and therefore I will get R2 is equal to 2. So if you observe here, in register R2 I am getting 2, in register R1 I am getting 4, and in register R0 I am getting 9.